Design of members subjected to bending, that is design of beams. Beams are basically two types. One is laterally supported or restrained beams. Other one is laterally unsupported or unrestrained beams. If beams are adequately supported against lateral torsion buckling, then they are called laterally supported beams. Whereas if the beams are not adequately supported against lateral torsional buckling, then they are called laterally unsupported beams. Design bending strength of laterally supported beams is governed by the yield stress, whereas in laterally unsupported beams, design bending strength may be governed by lateral torsional buckling strength. Next is the classification of cross section. Sections are generally classified as class 1, class 2, class 3 and class 4. Class 1 are also called as plastic sections. Class 2 are also called as compact sections. Class 3 are semi-compact sections and class 4 are slender sections. If we consider a cross section in which plastic hinge is formed in the middle, if we take the stress distribution in the middle, then in all the layers Fy stress is reached, whereas just beside only up to few layers Fy stress is reached. A plastic hinge is formed here, so this is called plastic hinge. Example of a plastic hinge can be a rusted hinge which can support small amount of loads. So this hinge forms plastic hinge and rotates. If we consider the first classification, that is plastic or class 1, these are cross sections which can develop plastic hinge and can have rotation capacity required for failure of the structure. And can form plastic mechanism. This is a mechanism whereas the second class is compact or class 2 sections. These cross sections can also form plastic hinge but cannot rotate due to local buckling. Before rotation only, the section gets locally buckled, whereas semi-compact sections or class 3 sections, these are cross sections in which the extreme fibers in compression can reach yield stress, that is Fy, So the extreme fibers will reach Fi stress but cannot develop plastic hinge or plastic moment of resistance due to local buckling. Whereas class 4 sections are slender sections in which these are cross sections in which the elements buckle locally even before reaching of yield stress, that is stress in the extreme fibers is less than yield stress, then itself the section gets buckled locally. These are slender sections. So when different elements of a cross section fall under different classes, that is if the web and flange are of different classes, then the section shall be classified as governed by the most critical element. That is, for example, if the web is plastic and if the flange is semi-compact, then the most critical is semi-compact, hence section is classified as semi-compact only. The classification of sections is done based on the width to thickness ratio, that is limiting width to thickness ratios given by IS 800-2007 based on compression element and based on the ratio of width to thickness. Classification of sections is done for outstanding element of compression flange for rolled section for B by TF, that is thickness of the flange, less than 9.4 and 9.4 epsilon and equal to 9.4 epsilon. Section is plastic. In between 9.4 to 10.5 epsilon it is compact. In between 10.5 to 15.7 epsilon it is semi-compact. Similarly, in welded sections for B by TF equal to 8.4 epsilon or less than that, it is plastic. Between 8.4 to 9.4 it is compact. Between 9.4 epsilon to 13.6 epsilon it is semi-compact, and greater than 13.6 epsilon it is slender. And in this too, B is defined separately for rolled sections and columns. B is the outstand width, whereas for welded sections B is the clear outstand width, whereas epsilon is under root of 250 by Fi. Similarly, the section classification is given for internal elements of compression flange, for web of an I, H or box section, for web of a channel section, for angles, compression due to bending. Both criteria should be satisfied. Single angle or double angle with components separated, axial compression, all three criteria should be satisfied. For outstanding leg of an angle in contact back to back in a double angle section, for outstanding leg of an angle with its back in continuous contact with another component, stem of a T section rolled or cut from a rolled I or H section, circular hollow tube including welded tube subjected to moment and axial compression, for each one based on the width to thickness ratio, whereas width in each case is defined in the form of figure. Here B is this, here B is this, here it is D. Here it is B again. Here B is clear outstand width. Here B is clear outstand width. Similarly, B here in built-up sections also B is defined. For hollow sections, hollow built-up sections also B is defined.